In this recording, we're going to learn how to factor polynomials. Specifically, we're going to learn some special factoring patterns. Let's start out with the sum of two cubes. You've learned all along you can't factor a sum of two squares, but it turns out we can actually factor a sum of two cubes, and it falls into this pattern. If you have a cubed plus b cubed, it's equivalent to whatever a plus b is, and then it produces a quadratic. A squared minus a times b plus b squared.
So I know that can be a lot to take in because it's kind of complicated and there's a lot of a's and b's. So one way to remember this is to use this little mnemonic device, same, different, plus. I'll write that out for you. What does that have to do with anything? Well, same, then different, not a plus sign, and then this one's always a plus. So for example, if I were to jump ahead to see what it looks like for a difference of two cubes, it follows that same idea. Same, if it's a difference, first thing is same, then different, and then it ends with a plus. Okay, so as we're going back to try to get this in our head, this sum of two cubes factoring pattern, same, different, plus.
Let's apply that to this example. First we have to identify what the a and b are here. We have to write it as two cubes. So first I'll identify that 64 is a perfect cube, 4, and x cubed is obviously a perfect cube, so I'm going to write that as a perfect cube, like so. And 1 is obviously a perfect cube because 1 to any power is 1. Okay, so now that I've identified the a and the b, 4x and 1, I can simply write it out. 4x plus 1, that's like your a plus b. Right? And then a squared, which would be 4x squared, so that'd be 16x squared. I'm squaring the 4 and the x. Minus a times b. Okay, so that's 4x and 1. Plus b squared. So that'd be plus 1 squared. And that's it. It might help you if over on this side you identify, okay, a equals 4x, b equals 1. Okay? Great. There's also a difference of two cubes. So this pattern, if you remember, the sum of two cubes started out with a sum here, and it started out with a sum. And that's how I kind of keep it straight in my head. I remember that sum of two cubes, a cubed plus b cubed, starts out with a plus b. You always have to have a minus in there somewhere. You can't have all these be positive with an a plus b. Otherwise, we'd have lots more terms than just 2. Okay, so here it's consistent. A minus b is the first binomial, and then all positive signs. Okay, so let's do what we did before. Let's express it. We'll identify the a and the b basically. I think that was helpful before. So we're going to say a is equal to something here cubed. So take the cube root of 27, that's 3. Cube root of x cubed, that's x. And b, well, the cube root of 8 is 2. 2 times 2 times 2 is 8. Alright, so basically I've got, I guess I don't need that parenthesis. I've got 3x quantity cubed minus 2 cubed. Alright, so we've identified a and b here. Now we can just follow the factoring pattern. Alright, so we've got 3x minus 2, and then a squared, which would be 3x squared. Let me rewrite that. That would be 9x squared. I'm squaring the 3 and the x. Plus 3x times 2, so that's 6x. Plus b squared. Okay, so that's 2 squared. Of course, you could check this. You could distribute the 3x to all the terms and the negative 2 to all the terms. You'd have a lot of opposites. And then you would end up with just 27x cubed and a minus 8. Okay. This is a review of factor by grouping. I think you know how to do this. Why don't you put each one of these into the panes of a box and then find your GCFs? Play the recording when you're ready for some help or you just want to check your answer. Okay, so I'll kind of go through this quickly because this is a review. Create your box. Now we're going to take the GCF of each row. So looking at this row, m squared. Looking at this column, m. Now from there it's pretty easy because m times what makes negative 4m? M squared times what makes 5m squared? Now I've got my factors. M plus 5 times the quantity m squared minus 4. I should look at this to see if I can factor it further. M plus 5 you cannot, but the binomial on the right is a difference of two squares. So we'll write it as m plus 5, m plus 2, m minus 2. Okay? That's the simplified, or excuse me, that's the fully factored form, the completely factored form. So now let's consider some more challenging, some polynomials of higher degree. So what we're going to say is these are considered to be in quadratic form. That's what we're talking about here. So if you have something of this form, I'll write it out. AU squared plus BU plus C, where U is an algebraic expression. That's what we're talking about by quadratic form, okay? So if we can see something of this structure, and in this case, well, we don't have any b, but in fact, we can consider this to be something squared and this to be the constant, okay? So this is in fact a difference of two squares, where 16x to the fourth is a perfect square. So we'll factor this as the difference of two squares. So we'll write that as 4x squared. Okay, that's square root of 16x to the fourth. And then the square root of 81 is 9. So we've got our difference of two squares, kind of like they're conjugates almost, or they're not conjugates, but they fall into that conjugate form, right? Now we look to see if we can factor this further. We have a factoring technique for sum of two cubes, but not for sum of two squares. We do have a factoring technique for difference of two squares. So the expression, the binomial on the right, can be factored further. Let's do it. We've got a square minus a square. So we'll call it 2x minus 3, 2x plus 3. And that's factoring this expression further. This is a toughie here. Okay, we're always looking for greatest common factor first. We should do that. So I'm looking at each term, and I see a 3 goes into all the terms. I'm also seeing that, let's see, p squared is the greatest amount of p variables. So we'll go with a 3p squared as our GCF. And we'll rewrite everything. Excuse me, that should be a 5. Okay, I'm dividing all the terms by 3 and a p squared. So the exponents reduced by 2, and we're dividing the coefficients by 3. And so now I'm looking at what I have in parentheses. It doesn't look very comfortable to me, but hey, I recognize something. This is kind of like something squared. Okay, so I could express this all as p cubed squared. That's p to the 6th. And I could express this as 5 times p cubed. So it's kind of like I've got that u in here. Okay, I'm kind of showing a structure here. This is the u squared, 5 times u plus 6. Let's come over to our box and see if we can factor out what's in the parentheses. Okay? See if this feels familiar to you. got a p to the 6th and a 6. I'm going to split this term in such a way where the terms add to 5 and multiply to be 6. Sounds like 2 and 3 to me, right? So 2p cubed and 3p cubed. Those add up to 5p cubed, so it's equivalent to what I have. Now, we can factor this. So in the top row, I've got a GCF of p cubed, and this row I've also got a p cubed and p cubed. You can fill in the rest of it. So we've got a 3 and a 2. So now we can write the factorization. So we've got our 3p squared before, and we just take the dimensions of the square. So p cubed plus 2, p cubed plus 3. Now we look to see if we can factor this further. We have a cubed, but we don't have a cube here, so we can't use our sum of two cubes technique in either case. 3 is not a cube and 2 is not a cube, so that's our simplest form. Our last one, we're going to try to factor this completely. So I'd like you to use any factoring techniques you have and play the recording when you're ready. Okay, so for this one, we're going to first look for our GCF. I see a 6 that goes into both terms and an a squared, so I'll factor that out, 6a squared. And that leaves me with 1a cubed minus, now when you divide this by 6, it's easier for me to divide by 3 in my head, so that's 250, and divide it again by 2, so that's 125. That turns out, guys, is a perfect cube. So now I see, all right, this is a perfect cube technique. So why don't you play the recording after you've tried to factor this with difference of two cube technique. Okay, so hopefully you got as far as you could with that. So 6a squared. I'm going to kind of go over here just for a second and identify that that's a cubed, so my a is a, and my b is 5. All right, that's 5 cubed. So I'm just going to use my technique of a minus 5. We start with its subtraction because it's a difference, and then we have all addition over here. So a squared, a and b, so plus 5a, and then b squared, so 25. And that's our completely factored form. Thanks for watching.